So, we will start our series of lectures. This will be in addition to our class will be taken in the video. Now, this probably is the first course you are doing in the department, means in naval architecture as such, or this will be your ship related first course. So, and the other course is of course marine hydrodynamics, that also I am teaching for you. So, that course is slightly different, that is more of fluid mechanics and more related to what you have already done. So, in this course this will be your introduction to naval architecture as such. So, this is the first lecture. Now, the way in which we usually do every year is the course is divided into, this there are 3 sections. You of course have the end semester exam for 50%, mid semester will be for 30%, and in the course of the lectures in between I will give you homeworks and tests, and for that you will have your remaining 20%. The textbook that we will be following for this course is this one. Okay. This is the book, Ship Hydrostatics and Stability by Adrian Biran. That is the name of the book. I suggest, like I said for the other course, it is there in the library. So, you take a copy of it from the library, or you take this from the library, not today, on Thursday after the class. You Xerox it and you keep a copy for yourself, because this is one of the primary courses you do in naval architecture, and this is something that you need for the rest of your, at least for your rest of your BTech and or dual degree. You need this fundamentals very strongly. Everything you study here you will keep using it throughout. Okay. So, it is very important that you have a copy of this book. You will see that you keep referring to it in the course of your study here. Okay. So, let us introduce ourselves to naval architecture first. The broad study of naval architecture has 4 sections mainly. The first one this course deals with is hydrostatics and stability. We will see later in the next slides what a detailed description of each of these sections. We have hydrostatics and stability as one of the primary sections. Then the next one is hydrodynamics, marine hydrodynamics. Then you will be dealing with structures, that is marine structures, and the last one is design and construction. So, we will see each of these sections in detail. Okay. So, what do we mean by hydrostatics and stability? Here we have given the broad definition as such. Of course, hydrostatics means that first of all, what is the condition for the ship? It is that it should float on the water. So, all the principles that deal with the floating of the ship is what you deal with in hydrostatics. Of course, you will be familiar with it already. You have already done Archimedes Principle and all that. You have done hydrostatics to probably a good extent already. The main concept is that of buoyancy, okay, the buoyant force. We will discuss it. Then stability. Now, for the ship, it is not just enough that the ship floats. It is also important that the ship floats upright. Means you cannot have a ship floating like this or like this. Okay, that is not the proper way for a ship to go. It is not ideal for either the materials on the ship or for the people on the ship. It is very uncomfortable. So, it is very important. So, all those mathematical laws and descriptions which deal with how the ship, what are the conditions such that the ship is like this, exactly like this, or it moves slowly, different conditions associated with it is what you deal with in stability. And this is how it restores to the original position when it is acted upon by different loads. Now, as such, the different loads that a ship will experience are wind, primary one, that is of course, wind acts on the above part of the ship, then waves, that is of course, you know what are waves. You probably haven't studied waves in detail, but the water waves is something that is very important for the ship's position. And of course, different conditions of loading means you have a lot of weights on one side, lot of weights on another, less weights on another side. This will cause the ship to move in a different direction. So, this is broadly what you study in hydrostatics and stability. This course, by the end of this course, you should be able to explain all these phenomena properly. Then we come to the next section, that is hydrodynamics. In some sense, we say that hydrodynamics is more complicated than hydrostatics. It is after all a more advanced subject. Then the main subjects that you deal with in hydrodynamics as such of course, what is hydrodynamics? By hydrodynamics we mean we are studying the flow of water around the hull and the effects of that on the ship. Okay? How does the ship move? How does the movement of the ship affect the flow around the hull, like that? It's basically about the flow of water around the hull. That is the primary definition of hydrodynamics. Now, we can broadly classify into a few subjects. First of all, you will have resistance, and resistance means what is the drag offered by the water to the movement of the ship. That is, when the ship is moving through water, when the ship is moving, the water offers a drag, like friction. So, that study how much is that and what are the components of that drag, that is what you mean by resistance. So, you have a course called resistance and propulsion, okay? That is an entire course in itself. So, depending on the drag, you will decide how much power has to be given. So, that associated study is what you call by resistance and propulsion. And propulsion, of course, means you have propellers on the aft of a ship. Propellers means those are you have seen on toys itself. So, they rotate, as a result of which a thrust is produced and the ship is pushed forward going against the drag. So, this is called propulsion. There are different types of propellers that you will study in the course, resistance and propulsion. Then the third part which we deal with in marine hydrodynamics is dealing with ship motions. It's called, the word used in naval architecture is sea keeping. That is a word used for this particular concept of ship motions. It means that when a wave comes and hits the ship, what happens to the ship and how does a ship come back to its original position. The study of all those is dealing with sea keeping. Okay. Then, of course, the last is called maneuvering or controllability. So, that means how does a ship go through water, means pierce through the conditions of like wind, waves, everything, and how does it move and how does it turn. Okay. A ship has to turn, a ship has to take a circle or something. So, all those things you deal with in maneuvering. So, all this comes under hydrodynamics in general. So, then the next section is we deal with structures. In structures, of course, you deal with primarily what is the material to be used. Metallurgy is an important subject. You have to study, you must have done already about things like yielding stress, bending stress, and at what point does a thing break, like plastic region and elastic region and all that. All those things are studied in structures. So, you first of all you decide on the material, you decide on all those yielding material, and then you design the ship in such a way that the total stress is always less than that maximum stress where it breaks or it becomes plastic. Okay. So, that study of the structural details of the ship is what you call as is marine structures. That comes under the category of marine structures. That is another 3 or 4 courses you will be dealing on marine structures. It's very complicated subject, and related to that is what is called as vibration. Vibration means because of, for example, because of the engine operating, the whole ship can vibrate to some extent, and you can contain it using different techniques. The study of all that is what you do in this course, vibration of floating structures. There is a course. So, and there is a topic called hydroelasticity. It's again similar to this. So, you are dealing with structures as such. So, this is another category of naval architecture. Then, of course, last thing I already mentioned, I haven't put a slide yet, slide in this, that is the ship design. That is also, of course, very important, ship design and construction. Ship design, mainly you study the layout, you study the engine requirements, you all those things, you study how the rooms should be, everything. You study the pipings or what you call as HVAC or something. HVAC means it's, you know that, okay, heating, ventilation and air conditioning. This stands for heating, this stands for ventilation, and this stands for air conditioning. The whole concept together is called HVAC. So, design of all this, and in finally construction. Of course, you send the whole design, you finally send it to the yard where it is constructed. So, all that comes under the last category. So, these are broadly 4 categories you can think of in naval architecture, and different courses you do in that extent, in that direction you will be doing. Now, our course of course is on hydrostatics. Before that, there are some ships generally you find in naval architecture. The one we deal with in design, the way in which we broadly categorize, The main ones are, one is oil tankers, you see this oil tankers, then the another category is cargo ships. Third, of course, oil tankers carry oil, cargo ships carry huge cargo, then bulk carriers, they carry materials in bulk, for example, rice or grains and all that, they will just carry in bulk, that is bulk carrier. Then you can have container ship, huge containers you will have. Then of course cruise ships, then warships is another different category of ships like aircraft carriers and all that, submarines, then high speed craft like the hovercraft, multi hull ships, hydrofoil. You do not know what all this is, but you will see each of this in detail in each of the courses. Then tugboats, workboats, etc. These are smaller types of ships. In general, you classify the main ones you deal with are the cargo ships, bulk carriers and oil tankers. These are the ones you will be mostly dealing with in your design and in all your studies. Of course, then high speed craft, slightly different set of hydrodynamics completely for that. Then so these are broadly the different categories of ships, and some more. This is just some information for you about naval architecture. Then there is also something known as a classification society. You should know that. That is, there are some societies that are given with the power that they look at the ship and say, okay, this is suitable for sailing in the sea. Means power requirements are met, the structural requirements, it seems strong enough, it won't buckle under the stress. So these conditions are met. So they give a certificate, and as a result the ship owners can then sail in sea. Without their certificate you cannot. Okay. The Indian one is called the Indian Register of Shipping, that is one of them. Like that you have the American Bureau of Shipping, you have the Bureau Veritas, Lloyd's Register. There are many more. These are some of the important ones, the more famous ones. So there is some, these are the abbreviations or the BV, ABS, IRS as they are called. These are classification society. This is very important. Okay. Now we will go into hydrostatics. Now the first thing that you have to know is we call it this is what we call it hydrostatic particulars. It is a naval architecture term specifically, and we will see what it means. That is, as a naval architect, for example, if you go to a shipyard, you will come across huge drawings. Okay, they will contain a lot. You have already done engineering drawings, so you know how a drawing looks like. So there you will see in the corner, as you must have written like your name, details of the drawing and all. In that corner you will see in these drawings you will see hydrostatic particulars, some things written. Now there are some terms that come up there, they are like this. The first one is, we call it, okay, suppose this is a ship. Okay. Now first of all, let us say this is the front of the ship, this is the back of the ship. Now in naval architecture terms we call the front of the ship as the bow of the ship. Okay, it is called BOW, bow, and back of the ship you call it as aft, or sometimes it is called stern. Each of this represents the same thing, stern or aft. So aft of the ship, so nobody will talk about the front of the ship or the back of the ship, they will only say this is the aft portion, this is the forward portion or the bow portion. It is also called forward portion, it is the same thing. Now usually around this region, it is a straight line. Okay, in this region we draw two lines like this. It is not at the very extreme end or at the very extreme front, means you see a little region is left here and it is actually somewhere here. Okay, it is a straight line, vertical line, and these are called perpendiculars. And this is called as an aft perpendicular AP, and this is known as a forward perpendicular FP. These are very important terms because you will see it in all drawings and nobody is going to explain to you later. So AP represents the aft perpendicular and FP is the forward perpendicular, representing the one representing almost like the end of the ship and the beginning of the ship. Of course, there is some region in the beginning, some region left in both sides, but in general it represents the beginning and end of the ship. Okay. So, aft and forward perpendicular. Now, the distance between these perpendiculars is what you call as LPP, which is the length between perpendiculars. So, this is the first hydrostatic particular. Okay. It is known as LPP, length between perpendiculars. There is next one is LOA, which is the length overall. It is this distance, whole thing, length overall. That is LOA is the next one. Then the next one is breadth. Breadth of the ship. Now, when you have a ship like this, okay, so let us say this is the forward part of the ship and this is the aft part of the ship, when this is the breadth obviously, and this is known as a half breadth from the aft, from the one side to the middle, okay, that is known as the half breadth. And in general, in fact almost always, this portion of the ship is very similar to this portion of the ship, means the ship is very symmetrical, it is never like these are unsymmetrical. So, what we do is we consider only one half of the ship. There are never, usually you never see drawings which have the whole portion of the ship. So, it is called half breadth. So, we deal only with half of the ship. And one more thing is, suppose you have a ship like this, okay, this is the forward portion of the ship, this is the aft portion of the ship, and I am looking from here. Then this side of the ship you call as starboard and this side of the ship you call as port. So, again nobody says the right side of the ship or left side of the ship, it is called starboard and port. Remember, if you look from the right, from the front it will be reverse, but otherwise you look from the back, this is starboard and this is port. Okay. So, you have half breadth. Then the next one is so this is the bow and this is the stern. Now, when a ship is put in water, you know that water extends to some height. Let us say this is the height. Now, this line is known as a water line. So, it is usually written as WL. So, when you draw a line, you will see one line like this with a, and the right side will be written WL, that is the meaning of it. It is either WL or it is LWL, load water line. It just means that the loads have also been put on the ship and this is where it is. It is the same thing, load water line or water line, it represents the same thing, it represents where the water is located, that height of water. And this height of the ship, the total height of the ship is known as the depth of the ship, whole thing, and this is the whole thing, okay, up to here. Then this one, this region, that is underwater, in fact it is more important than the depth of the ship and it is known as draught, or it is also known as draft. The difference in spelling is just a difference in British and American pronunciation. So, it is the same thing, draught and draft, we will use this. So, I think this book mainly follows draught. So, you call this to be the draught of the ship. In general, the depth of the ship is denoted by D and the draft of the ship is denoted by T, okay, and the breadth of the ship is denoted by L by B and the length of the ship by L. So, and this is usually called LPP, but and this is breadth, depth and draft. Then of course, you can have in addition one more length. We already talked about two lengths, length between perpendiculars and length of overall. You also can have this length, that is known as the length of water line, LWL. So, three lengths and breadth, depth and draft. Then another term, that is two things that are important, is suppose the, as you can see this ship, that is this is the length of the ship as such, then okay, this is the, let us say this is the center line. Now, if the ship is, if this is horizontal, okay, we call it as even keel, and in usual practice you will see that it is never horizontal. The ship means, what this means is that ship is exactly horizontal, okay, because but waves are there like this, right. So, because of which it will move like this or it can move like this. This process is called as trimming. The word is trim and the process is trimming, okay. And similarly, like this, the ship is like this, instead of remaining horizontal in this direction, it can go like this or like this. That is another, it is another degree of freedom, another direction of another direction, that is, that process is called as heeling. It is not used interchangeably, like you cannot call this trimming and this heeling, it is all fixed. This is trimming always and this is always called heeling. So, those are now next thing is, that is, you should have some Cartesian coordinates are always fixed for the ship. This direction, okay, the length of the ship is known as, is always given as the x direction, no difference to that, and the direction that is showing the breadth of the ship, okay, that shows, that is the y direction always, and the direction that shows the depth of the ship, that is the z direction. It is always like this. So, this is x. So, if the ship is like this, let us suppose that the ship is like this, this is the x direction, this is the y direction, this is the z direction always, and also this direction is called as the longitudinal direction, this direction, okay, this x direction it is the longitudinal direction, the y direction like this is known as the transverse direction. So, these two terms you will, this is used very much because you will come across things like moment of inertia, you will come across longitudinal moment of inertia, transverse moment, you have to know what is transverse and what is longitudinal. This is longitudinal, this is transverse, and the other one is of course vertical. Okay, then okay, next is so, I already told you we divide like this. This is the aft perpendicular and this is the forward perpendicular. Now, usually the distance between the forward and the aft perpendicular is divided into a fixed number of, let us say 10 equally spaced points, and you divide it like this, like this. It is not 10, but like that you divide it into 10 such sections, and each of these vertical lines that you are seeing are called as stations. The word is stations. Now, you can number it in different ways, that is, you can either call this as station 0, station 1, station 2, like this. Let us say this is station whatever 10 probably, then, or you can number it from this side, station 0, station 1, station 2, like this. Okay, you can in general you see it numbered in this fashion, but you will see some of the drawings will show it in the other fashion, from the right side it goes to the left side. Okay. So, let me see if this will come in this. Yeah. Okay. You can see that this is how it is. Okay. It is that sections. This is how you are having station 0. It is starting from station 0. It's coming down to station 10 to the front. Okay. So, this is the stations. Similarly, now, this section you can also divide it in this fashion. Okay. Last time we divided it like this, right now we are dividing it like this. So, these lines are called as water lines, and you remember there was one called load water line, which is basically representing where the water is. Just like that, you are having different water lines. So, you name it in the same fashion, like you call them water line 0, water line 1, water line 2, like that you divide it into different sections. So, these lines are, so we now have stations vertically and water lines horizontally, and one more is there. Obviously, you can cut it like this. Okay. If you consider this to be the length of the ship, this is station, this is water line, this is known as, the third one is known as buttock lines. That of course, if I will draw it in the next figure, then in that half breadth you start from one end, and the middle part is known as a center line or a center plane. It is called as a center line or center plane. So, from center line you go up to the maximum breadth. Now, there is a important thing known as lines plan. Lines plan in general represents a set of drawing, or it is a complete drawing in itself. That is what you call by lines plan. It is a drawing which will include 3 sections. You already know engineering drawing, so you will know how this is done. Means you will see the ship in 3 views. Means if you have a ship like this, you can see it like this, then you see it like this, and then you see it like this, 3 views. Okay. We can do one thing, we can call this front view, top view and side view. So, these 3 views you will have. Okay. 3 views. This is the top view, this is the front view, and this is the side view. So, the top view is also known as a plan, or it is known as a half breadth plan. It is called half breadth because we are drawing only half the ship. Means when you look from here, you have a total ship, we do only the top or the port part, we do not do the starboard. So, you call that the half breadth plan, this view. This you call it as the shear plan, and this you call as the body plan. 3 views. Okay. Now, let us see how the stations and all that will look like in this. So, I will draw. I will explain what this is. We are drawing only half the ship. So, this is the center line, it will come like this. Now, this drawing itself is okay, it is gone out actually, sorry. Okay, they did tell me they cannot show it outside. Okay. So, there are 3 views like this. So, as I said, this is actually one course. The only thing you do in the course is do this drawing. Okay, let us call lines plan drawing. So, you will be given a huge sheet of paper and you will be drawing the whole thing there. I mean, it is a very complex, it is very tedious rather. You have to be very careful, you have to be very accurate. I will explain what the different points are in drawing this. At any rate, finally, you will be ending up with these three views. So, you will have the front view, top view and the side view. So, let us look at the stations first. How will the stations look like in the front view? It is obvious, it will look like this, right. Stations will look like that. Now, how will it look like in the top view? Same way, it will be like this. right. These are stations, maybe let us call this station 0, station 1, like that, different stations. This is also stations. Now, the water lines will look, how will it look like in the front view? We are obviously slicing it like this, so it will look like this. Now, these slices will look like this. Actually, this is the shape of the ship. When you slice it, the shape of that slice is like this, right. So, that is what you are seeing here in the top view. So, when you are looking from the top, you are seeing that slice actually. Okay. So, this is how it will look like. These are water lines. These are water lines looking in the top view. I mean, when you see it in the top view, this is how the water lines look like. And actually, this line, okay, is the region where the ship is the thickest, obviously, okay, and then it is becoming thinner. The other water lines, it is becoming thinner, okay. Then the slightly more difficult to visualize is probably the body plan. The other two is very straightforward. Then now, when you look at the body plan, you see you are actually looking from here, okay. The ship is like this, you are looking from here. Now, how will the stations look like? Now, actually see, station is a slice like this, it is also like this, the ship is like this, okay. The shape of the ship is like this. When you look like this is how the ship is. So, when you look from here, the station will look like this, right. So, that is what I have drawn here. So, you have the different stations. Now, and the way in which the stations are drawn is like you have two sides here. As I told you, means right side and left side. As I told you, the starboard of the ship is exactly like the port of the ship. There is no sense in drawing both the forward, I mean both the port and starboard, it is the same, it is just a mirror symmetry, okay. Now, so what we do is this, but the front of the ship is not the same as the back of the ship, means they will be completely different, like front will be highly streamlined, the back will be blunt in fact. So, they will be different. So, what we do is, suppose you have a ship like this, this set of drawings represents the stations from the midsection to the front, the right side, it is always like that, the right side represents the front part of the ship. Probably it will take a little bit time for this to sink in, but then the left side of the ship actually represents the aft side of the ship, okay. Oh, it is going out, oh I see, sorry, okay, all right. Okay, the left side is the aft, so it is like this, the front side always represents, is always given on the right side and the aft is on the left side. It's, so, and this thickest, the outside line, okay, which part of the ship do you think it will correspond to? Center, someone told, yes, it represents the center because it is the thickest, and it is thickest in the center, the ship is thickest in the center, it comes like this, right, it is thickest in the center always, midship, it is called the midship, and so this actually represents the midship. Likewise here also. So, after you end here, means when you are going like this station wise, when you end at the midship, the next station is this is also midship on the other side, then it goes in, means it keeps going in, means it is going backward, and similarly this is the center, and as you keep going up you are actually going front, and the one at the very top, this actually represents the front of the ship, the probably most likely the forward perpendicular, okay, this one, the first one. So, you name it like this, let us call this station 0. Now, you might see different kind of naming, but that is okay, station 1, station 2, station 3 like that, and similarly station 4, station 5, so on. Oh, again I have gone out, okay. So, you will have these stations named like this. Now, let us look at some figures. For example, this is a body plan of some it is a cruise ship, so it is a body plan of that. So, you can see again in the body plan, yeah, it is the same, they have number point, you can have 0.5 station, it means that it is a station between station 0 and station 1, that is 1, and the exact middle point they have drawn another station. So, it becomes station 0.5, you can have that. Okay. So, station 0.5, 1, like 1.5, then 2, 3, it is like coming from the front. So, this is the frontmost region, it's coming towards, and this around this region is the center of the ship. So, this is station 10, then this is again the center 11, it is going inside, means it is going behind, it is going to the aft, it keeps going till it reaches station 20. Okay. This is how this is the general arrangement. Okay. This A and B, it is not required for this, but this is the station definition of the course. Then of course, these are the water lines like this. Okay. These are at different heights, 2, I think it is 2-inch probably, 2-inch water line, 4 water lines, 6, 10, like that, different water lines. Okay. These are the water lines. Then so you will have water lines and stations. So, how will the buttock lines look like in this? No, see, you have the ship like this. So, but you are actually slicing it like this, right? Buttock lines are like this, these are called buttock lines, these are water lines, these are buttock lines. So, when you are looking from there, it will look like this. So, these lines, these numbers given here, these are actually vertical lines representing. So, this 28 buttock line, 24 buttock line, 20. So, these are buttock lines like this. Okay. So, you have all these lines. So, this is in general how a body plan looks like. Then this is a shear plan, means the front view. Now, these different lines are actually the buttock lines, right, like this. If you see in the front view, the centermost will be the outermost, and as you keep going like this, it will become like this. Okay. It will keep becoming like this. So, this is the shear plan, and this is the other thing, the half breadth plan, where you are actually showing the half breadths. These are the water lines in the top view. So, it is very important that you get this idea. This whole thing of lines plan is very important, because it is the so to speak the crux of your naval architecture. From this you develop the design, from this you develop the marine structural part, the structural design of the ship, like that. Okay. So, from this you start everything. So, this is the most important, probably the basic thing you need for the design of a ship. And this is usually represented as, that is, this is the drawing, you will have the big drawing. Now, in a shipyard, this is usually represented as what we call as table of offsets, or it is called the offset table. Okay. It is usually designed like this. It is basically the drawing in a tabular form. You have just reduced the drawing into a tabular form. So, this is there. So, let us say 0.4, 0.6, 0.8, like that. That means, what this table represents here is, this represents the series of stations like this. Okay. Stations, it is going from 0 to whatever is the maximum, and water lines, it is going either from the bottom up, mostly from the bottom up only, 0, 1, 2, 3, 4, like that. This is the water lines. Now, so we have right now an intersection of a station and a water line. Now, at that intersection, what is the half breadth? Means, what is this height? What is this length? Not height. This, what is this breadth actually? What is this breadth or half breadth? It is given here, it is a half breadth. So, this distance, what is this distance? That is 0.4. So, you have the intersection of water line 0 and the intersection of station 0. You have the half breadth is 0.4 probably meters. So, 0.4 meters. Okay. So, this is what an offset table is. So, when you are going to do that drawing in the lines plan for probably next year, you will be doing this. So, when you are doing this, you will be given the offset table, that is what you will be given, you will be given an offset table, you drew the whole drawing. Now, when you are doing the when you are doing the whole drawing, there are two important things that we consider in a lines plan drawing. One is of course the accuracy, and two we call it fairing. Now, what do we mean by accuracy? Let me see if this will come here. Okay, what I am trying to show here is this a part of that whole drawing. They have given here the body plan, I mean the half breadth plan, the profile and the body plan. Now, see what we mean by accuracy is, let's assume that we take, let's say this one, station 8 and its waterline 4. Okay. Now, this is the intersection of station 8, this is that vertical line, and waterline 4 in the front view or the shear plan. Now, in the top view it should represent, obviously it should represent waterline 4 and station 8, it is, that is what it represents in the front view. What it means is that you have here a waterline, in this you have a waterline like this. So, that intersection of that waterline and that station here and here will be in one straight line, right. So, it should be in that straight line for one thing, and it should hit that waterline 4, because here you are drawing a waterlines. So, that intersection of that waterline 4 and that station 8 in this drawing also should match with that. Of course, it is the basic engineering drawing principle, but I am just repeating it. So, this kind of matching should always be perfect. Similarly, in this drawing also you will have this waterline 4 and station 8. So, if it is the same waterline, it means it should be on the same straight line, like waterlines are one straight line, this is one straight line waterline, right. So, this waterline 4 should match with the waterline 4 here, and that station which you draw here, that station 8, when this station station 8, the intersection of that station 8 and the waterline 4 should match there also, that straight line. So, it is the basic concept of this is what we call as the accuracy in, this is what I mentioned by accuracy in this drawing. So, it is very important, it is and I mean these are the things that, for example, if you do not have this accuracy and if you are doing this drawing especially for a real shipyard, if you are, I mean after your study you are doing it for a shipyard, this is probably one of the things you might be doing. And of course, another thing is that right now almost nobody really draws the whole thing, it's gone out of practice. You use softwares, okay, I will write here, you use different softwares, mainly things like AutoCAD, that's it's done on the computer. So, you just draw it there, it's not simpler, it's time consuming still, but it's not as tedious as drawing it. Okay. You do it on a computer, it's much more accurate, and if you do it carefully, it will be exactly accurate, means all those, because it's done by computer. So, this is what we do. So, in that drawing also you will be doing AutoCAD as well, you will be. So, this is the first part of lines plan. Then the next one is called fairing. By fairing we mean that you cannot have abrupt changes. For example, you cannot have waterline going like this, okay, sudden change in waterline, or any of those lines, especially waterlines, you have some sudden drastic curvatures, that is not allowed. It is called fairing, because as you know, this will straight away goes to the shipyard and they cannot make a plate bend like that. Okay. So, that is fairing. So, these two things are important. Okay. This is about the drawing. Next is we have a couple of coefficients, we call it. We call it these are a so as I told you, in hydrostatic particulars we have LPP, breadth, depth, draft, and we add this as well, coefficients of form, draft, and yes, and the coefficients of form, 2 or 3 of them are very important. and some of them are, the first one is we define a coefficient as Cb we define something known as Cb as a block coefficient. It is defined as, oh, this is one thing I forgot to mention, this sign. That is, in the hydrostatic particulars there is one more thing, that is this one. It is known as displacement. It's the there are two terms associated here. One, both of them represent displacement. One of them is the volume and the other is the mass or the weight. So, actually the next lecture is about this Archimedes principle. So, I won't do it now. So, but you know what it is, that is the concept that the the weight of the body is equal to the weight of the liquid displaced, or the mass of the body is equal to the mass of the liquid displaced. So, we can say this. So, the volume of liquid displaced, right, the volume of the liquid that is displaced by when the ship goes in, that is given by this volume del, okay. That is known as the volume of displacement, volume displacement it is called. And this symbol, if you might have used it in mathematics probably, or in the later course of mathematics you will see it. It is known as del operator. It is a del operator, it is called del, so we call it del. Then this is of course delta, that is also a common mathematical term only, it is called, it is the delta. So, this thing volume, now you know that del into, this is again Archimedes principle, but it is like this, rho into del, this, where rho is the density of water, this will actually give the weight of the body, we will come to that. But this rho into del is what you call as delta, okay. This is known as the weight of the ship, mass of the ship, and into g will give you the weight of the ship, okay. So, this is known as the displacement, and this is also given in the hydrostatic particulars, another thing known as del. Then, so this Cb is defined as, block coefficient is defined as del divided by LBT, where L is the length of the ship, B is the breadth of the ship, T is the draft of the ship, okay. Not the depth, it is the draft of the ship, okay. So, this is the first coefficient of form. So, this Cb is always given in these line span drawings, it is always given there. And as you can imagine, as you know, these values will be ranging from 0 to 1, it does not cross 1, okay. And larger ships usually have it in the range of about 0.8, like that, by bulk carrier. By larger ships we mean, okay, in general the range of ship is from, let us say, maybe about 10 to 15 meters, we are talking about small ships, small boats in fact, and we can go up to the maximum, I believe, is around 500 meters. I think this is the largest length, maybe 550 meters, something like that. So, this is basically, this is the range of the length of the ship. This is the length overall, total length, and okay, and usually you have the bulk carriers, oil tankers, these are the kind of big ships, these are the big ones, and some of the cruise ships are also big. And on the other side you have small boats, you have high speed vessels, you have these small boats that you see on the ships in the water, that is the small boats. So, they have a lesser block coefficient, but that is not important. The important thing is Cb is del by L, that formula you have to remember. Then another coefficient of form is the midship coefficient. It is written as Cm now Am represents the AM represents the midship sectional area. What does that mean? That is, when you have a ship like this, you take the go to the midship, the middle part of the ship, you slice it like this. This whole area, okay, this whole area is what you call as a midship area. That is AM. Okay, and okay, these are 2 or 3 terms. One is the mid section. This is whenever you talk about sectional area, there are 2 types of areas we will come across. Sectional area and okay. So the first one is sectional area. Sectional area means, as I told you, this area, okay, like this. It is an area like this. So whenever you are slicing, you see an area like this. I mean, I think it's obvious now. It's like this. That is the sectional area. Then the next one, water plane area, is if you slice like this. This area means you take a ship, you slice it like this, and so when I look from the top, oh, okay, it will be like this. Let me put it like this. This is okay. This is known as a, this is of course the half, but the whole thing is called water plane area. You can take the whole thing. Okay, this is the water plane area. So 2 types of areas that you will, again, this is very important. Like this, today's lecture is very simple, but it's full of terms which you have to know if you want to do anything. I mean, if you get confused with these things, you will see everything gets confused later. So these things like water plane area, because from this comes different thing. I have seen in our vivas, usually people get, they are totally confused which is sectional area, which is water plane area, or you will say the midship, the centroid of the water plane. Sometimes they say that it just means you have a section like this and the centroid of that. They are not sure if it is this centroid or if it is some other centroid. Okay, you understand? So this concept of water plane always means you are looking like this region. You are looking from above. You are looking at this section. That it's not. Let's not use the word section. That region, that area is called as always water plane. So that is called water plane area. And when you look from here like this, this area is always known as the sectional area. Okay, and so this is what we are talking about, midship sectional area divided by the breadth into draft. Okay. Okay, that is the, then okay, actually this figure says that, you see this is the sectional area, this is that section, you are seeing the section, and this is the breadth, this is the draft, right. As you can see, the ship won't, it won't be in the whole of the breadth into draft. Some will be left. So this is midship sectional area. Then there are a couple of them. Should I stop now? He showed something now. Okay, all right.